Introduction. Slope failure. An earth or soil slope failure is the slope surface of soil mass in geotechnical terms. Slopes in soils and rocks are common and they can be natural or man-made. Slopes can be classified into two types, namely infinite slopes and finite slopes. Slope failure is defined as the phenomenon of large soil masses sliding down a plane or curved surface with respect to the remaining mass, causing the slope to collapse abruptly as a result of the weakened self-retained ability of the soil, which is usually caused by rainfall, earthquakes, and other natural forces. Issue in engineering practice. In recent years, due to a lack of suitable flatland and other factors such as magnificent scenery, fresh air, exclusivity, and so on, the development of residential buildings on hillside has increased dramatically. Gui and Tan 2006 found that 60% of failed man-made slopes were attributable to design issues alone, based on 49 cases analyzed. This shortcoming in design is usually due to a lack of knowledge and awareness of subsurface conditions and geotechnical problems. Furthermore, landslides caused by construction errors done, including workmanship, materials, or a lack of site monitoring accounted for 8% of all landslides. A combination of design and construction errors caused about 20% of the landslides analyzed. Governmental departments and relevant associations have developed standards and policies to ensure strict approval procedures for hillside developments. More importantly, the formation of the Slope Engineering Branch under PWD on 2 February 2004, which also commissioned and developed National Slope Master Plan study aimed at improving current slope engineering and slope management practices. Other initiatives include the Malaysian Board of Engineering, which is also known as BEM, introducing accredited checkers for geotechnical and structural designs of hillside developments in order to reduce the risk of landslides and improve slope management and engineering. Types of slope failure. Soil slope failure can be classified into four categories in general. First, translational failure. In the case of infinite slopes, translation failure occurs when the topsoil is parallel to the slope surface and has uniform soil properties. When a slope has no definite boundaries and the soil under the free surface is thought to have the same properties up to identical depths along the slopes, is said to be infinite. Second, rotational failure. A rotational slide with its point of rotation on an imaginary axis parallel to the slope is a common type of failure in homogeneous fine-grained soils. Third, wedge failure. Wedge failure, often referred to as block failure or plane slope failure, results in an inclined failure plane. And last but not least, compound failure. Compound failure is a combination of translational and rotational slide failure, as the name implies. Factors of slide failure. The failure of a slope can be caused by a variety of human and natural forces. In general, slope failure occurs for two causes. First, increase in shear force. When the load on the soil mass increases, the ability of the soil particles to bind together decreases, resulting in slope failure. Second, decrease in shear strength of soil. When the bond between soil particles weakens, it also loses its shear strength. Effects of slope failure. Slope instability, which results in landslide, poses a considerable risk to human activities and is frequently accompanied by property destruction, injury, and death. Not only does it degrade the quality of the soil nearby, but it also has the potential to block and damage the road.
Literature review. Use three-dimensional finite element analysis to predict the impact of horizontal drains on slope stability under rainfall, landslides, rock avalanches, pyroclastic flows, and lava flows can already be modeled using demographic information systems based on digital elevation models, said Chai. Hutchinson at years 1988, also in terms of the proportions between rotational and translation slides, compound slides, arc classified as intermediate form. Compound slides have non-circular slip surface created by a combination of a steep, curved or planar back section and flatter sole. Walker at 1987 says that this instant slope stability study used a landslide analysis to estimate unstable slope mass, strength, or pore pressure characteristics. The beginning of landslides can be detecting or sliding. Mid-slope can be assessed. Last but not least, subdivided slope movement according to age. When a slope movement has happened in recent decades in a slope that has not yet been the focus of mass movements, it is referred to as recent. The term ancient refers to a movement for which there is no historical record. The event that contribute to a rise in shear stress and a reduction in shear strength are the causes that dictate sliding movement in a slope, said Zaruba and Menkel at year 1969, also Varnes at year 1978.
Hi, Assalamualaikum. My name is Ahmad Azmi bin Amil. My metric number is AF190186. So let me explain about the application of any standard for slope remedial technique. As we know, slope failures are common in many parts of the world which occur due to manifold reasons and they result in huge losses to the respective locales. So there are three proposed remedial methods which are helpful in minimizing the chances of approaching slope failure. Number one is geometrical method. This is the most common method that has been used. This method is usually simple and less costly as shown in figure below. The changing of the slope angle from steep slope to a gentle slope may increase the stabilization of slope and the angle is usually supported by grass bonding together with soil. Number two is drainage method. Drainage method is one of the slope failure factors. One of the slope failure factors is saturation and poor water pressure building up in the subsoil. If drainage system had been provided, the chances of building up poor water pressure and saturation of subsoil can be minimized. In general, this method is used in combination with other methods. Surface drain was used mostly with geometrical method while the subsoil drain is part of the method combined with the retaining structure. Last but not least is retaining structures method. This method is generally more costly. However, due to its flexibility in a constrained site, it is always the most commonly adopted method. The principle of this method is to use a retaining structure to resist the downward forces of the soil mass. This method also involves rigid slope surface protection such as shotcrete masonry and stone pitching. It also may reduce rainwater infiltration and prevent slope erosion of the slope-forming materials. Thank you. That's all from me.
Best technique of slope stability. For retaining wall, we prefer tight back wall. Anchor or tight back walls are the greatest option when coping with loose soil or rocks. The purpose of tie backs is to reduce pressure and slippage on the ground. Before filling the ends with concrete to serve as anchors, deep cable rods or wire rods that go horizontally into the dirt must be installed. Drainage method, we prefer surface drain. The drainage system, on the other hand, must be maintained to function properly. Subsurface drain are more difficult to keep and keep working order than surface drain. The most frequent subsoil drains encountered in retaining structure are weep holes and cut-off drains. This strategy is frequently used with other methods. Subsoil drains were utilized in conjunction with retaining structure where surface drains were used in conjunction with geometrical approach. A surface drain may discharge more water to lessen the effect of high volumes of water absorption by the slope, especially during heavy rain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aminah Hakim binti Abdul Halim with metric number AF19072. I'm going to present about long-term stability. Okay, so I'm going to present about retaining wall. Okay, so we're going to use the pre-add strategy. This is the figure. Okay, so first, the pre-add strategy was used as the foundation for the four ways shown in the figure from the slide before. All of this approach incorporate a component into the soil strength of the pressure acting on the building. And then, the speed-to approach apply a factor of safety to the resisting soil force, whereas the next total pressure methods define the British Steel Corporation piling handbag 3 applies a factor of safety to the net resisting soil and water force. Next, the strength approach which factor in the shear strength of soil is comparable to the method used to calculate slope stability. Okay, and then limit equilibrium study, in addition to being used in design, determine the depth of penetrations. And then the result of the study are affected by the regime in the soil. Okay, and then the next is tie back wall technique. So we are using limit equilibrium for design. So a design technique for a more brush instance including sloping backfill and reserved soil types. When the failure plane is totally within the abutted component of the anchor, this is referred to as internal stability. Failure planes that are fully behind the anchor are studied as mobile, whereas failure planes that are inside the anchor are analyzed as intermediate stability. Okay, so this is internal stability. So depict the internal stability case. Equation 1 is the important equation for PREQD. So by adjusting alpha and gamma until the maximum PRQD is solved, equation 1 is solved by characteristic the geometry of possible failure surface. That's all. Thank you.